All right, hi there, and welcome to our next video. This is for Learning Target 1.4 Inverse Functions. Again, we're using these videos if you're absent, you go on vacation, you need a little review. So we do not do the warm-ups on the video. Those are for the in-class activities. So let's jump right into finding inverses. So if you recall, a relation is a set of ordered pairs. So we need to know that in order to find inverse functions. So we have ordered pairs as a relation. The inverse relation is the set of ordered pairs that's obtained, or we get it by exchanging or flipping the coordinates of each ordered pair. So exchanging, I'm just going to say flipping. So we flip the x and the y. Makes a little more sense. So the domain of the relations, remember domain used to be the x. That becomes the range. So the x of the relation becomes the y. That's because we're going to flip coordinates. So when we do an inverse, we just flip the coordinates or the ordered pairs. And that range of the relation, so the y's, that would make sense, then become the x's. So pretty straightforward when we have ordered pairs. All we're doing is flipping the x and the y. It's that simple. All right, so let's look here. We have two relations, our inverses. If and only if, whenever one relation contains the element AB, the other relation contains its opposite BA. So we flipped it. They used A and B. We say X and Y or YX. It's the same thing. But if you look at here, we have 1, 5. So that it should be 5, 1. We flipped the 2. It's 2, 6. So that would be 6, 2. And then 3, 7, 7, 3. So that means this is the inverse relation. Okay, so that's our first target. So let's look at example 1. I can find the inverse of the relation. So again, ordered pairs. So what I'm going to do is I'm going to find the inverse. Listing my ordered pairs, it becomes 6, -8. I flipped these two. The next one, -2, 6. And the last one, -3, 7. We do not change positives and negatives. We just flip the XY becomes YX. So this is it. Okay? Let's move on to the next one, inverse functions. So functions are a little different than relations. Remember, when we look at functions, that means our x value can't repeat. We'll get into that a little bit later. But I want to go over the steps and the definition for this. So for inverse functions, what that means is it's a function that will undo. As you recall, we always undo things by finding the inverse. So with addition, we would use subtraction. That's the inverse operation. So with inverse functions, they just undo the function. So we can write the inverse function. So the original function is f of x. We're very familiar with that. The actual inverse function, we write f to the -1st of x. This is how we write the inverse. So it's written that -1 tells us that is an inverse function. That's all it means. We're not going to do anything with that number. That's just how we use function notation. So f of x, like we said, it represents the function, and this f to the -1st of x represents the inverse of the function. So then let's look at the steps. So when we are given a function or equation, we like to call it too, we first change our f of x. So that's the part that's hanging over usually to the left. If you see it in here, we're going to change that to say y. And then what we're going to do is we're going to switch the x and y spot. So we're actually going to move the x over here and the y where the x is. And then it says solve for y. I like to also say we isolate the y. We get the y alone. Or we solve for the y, meaning the y is by itself. So then to put it, when we finish, we change that y to say, this is how we're going to note it. So you're going to get an equation, but we're going to, instead of say y equals, we're going to say f to the negative first of x equals. So that's how we're going to do it. These are our steps, so we're going to go through them for each one. So for the first one, finding the inverse of the function. So remember, we have to change this to say y. I'm just going to put it above there. And then we have to change, and then it says switch the x and the y. So I'm going to rewrite it. So now it's going to be x equals, because remember, we're switching the x and the y spots. So x equals 3y minus 1. So that was step 1 and 2. It's that easy. You're going to change, the f of x becomes a y, and basically the y goes where the x is, and the x goes where the y is at, and you just rewrite it. So now you have an equation, and you are actually going to isolate. You want to get the y by itself. So we're moving everything away from the y. So if I go ahead, put my line in when I solve, I like to do that. It just keeps things nice and neat. I get rid of, I'm working on the side where the y is at. I have to get rid of any addition or subtraction first. So I'm going to add this one to both sides. It's going to cancel over here, and I get x plus 1. I'm going to write it that way, equals 3y. And my last step is to get rid of any multiplication or division. If I notice here, I have 3 times y, so I have to divide both sides by 3. Again, we're isolating or getting that alone. And then I do a long fraction bar because I'm dividing all of the things by 3. And remember, we're not solving because we're solving for y. We are just going to get another equation or another function. It's the inverse function. So we're going to end up with something like this. So I'm going to rewrite it in 2 different ways. So function notation. Instead of the y, remember it says instead of putting y equals, we're going to change it to f to the negative first of x. That's just how we write y once we get the inverse. So equals, and then I can write everything here. So x plus 1 all over 3. There's also an even better way to write it. So I'm going to show you how to split it up, because when you divide by 3, you can actually do x divided by 3 and 1 divided by 3. So this might be a way you see it too. F to the negative first x. Again, that's just how we write our y for the inverse. Equals. And then remember, I'm going to put a little 1 where that x, so it's actually 1/3 x, because it's like x divided by 3. Whenever you divide by something, it's the same as timesing by that fraction. So plus 1, again, divided by 3. I just split it up because sometimes you're going to see it like this. You have to know these mean the exact same thing. Okay, so we found the inverse function. All right, let's go to example B. We have f of x equals x minus 8 divided by 3. So again, we have to change our f of x to say y. And then step 2 is we're going to flip these. So I'm going to get x equals y minus 8 all divided by 3. That's step 1 and 2. I just flipped them. Okay, so now I'm going to try to get the y all by itself or isolate it. So as you recall, this is the only time we do things a little bit out of order. Whenever you have a big long fraction bar with more than one thing on top, term, and you have something here, we have to get rid of this divided by 3 first. So what I'm going to do is I'm actually going to times both sides by 3, because that's dividing by 3 times 3. This cancels, right? And I get 3x, 3 times x, equals y minus 8. Okay, now we have one more step. Get rid of the minus 8. So we do plus 8 and plus 8. So we can't add these terms together. That's a 3x and that's an 8. So we're just done. That cancels, and I'm left with, remember, I'm going to change my y into f of x. So I have that little box down there. I forgot about it over here, but that's where we're going to write our answers. So I'll just put an arrow down here. So f of x is now our y. Y equals 3x plus 8. Voila. All right, so I want you to look at these steps. You are going to go ahead and you are going to try the checkpoints for 1 and 2. So pause the video, and then what I want you to do is check your answers against mine. Okay, so for steps 1 and 2, you should have had that this was a y, and that's the x, and you would have switched them. X equals negative 2/5 times y, sorry about that, plus 1. And then we know right away, we're going to get rid of this plus 1. We're going to do minus 1, so this becomes x minus 1 equals, that cancels on this side, negative 2/5 times y. So remember, this is how I do it. Instead of timesing, when we have a fraction, we need to multiply by the reciprocal. So what happens here is we are going to take negative 5/2. So the reciprocal means we flip the fraction, and I'm going to times that by the quantity x minus 1. Okay? And then again, if we were timesing by that negative 5/2, those cancel there. So that would equal y. So when we go to write this, so here this is as simplified as it gets. So instead of f of x, the inverse is f to the negative first x. So remember that we get rid of that y. So I replaced the y for you with the typing. And then we just have the negative 5/2 times that whole quantity. So again, I could use the times symbol, but I'm going to use parentheses, and it is x minus 1. We are done. That is our inverse. Okay, let's flip to the next page of notes. So flip to the back. Now we're going to be looking at finding the inverse of a linear function we're actually going to be using ordered pairs and tables. So this first example here, in a particular function, f of x, so remember, you might want to label that. Whatever's in here is our x, and whatever's out here is actually our y. So it's very easy to find the inverse of these. Again, this is our x, g of whatever's right next to it's the x, and then this is what we call the y. All we have to do is flip these and then write it in function notation. So right away, I'm going to write f to the negative first, and then my new x, I have to flip them. So my y becomes my x equals 2. So I just have to put that negative 1 there, and then I'm flipping the numbers, my x and my y. So then g would be to the negative first because it's an inverse function. And then instead of the x, which was 5, we're flipping it. So 12 becomes the x, and then it equals 5. That's it. All right. Go ahead and try B for me on your own. We didn't do an example there, checkpoint, but I want you to try B on your own, just based on what I did here. I just flipped them. Okay, so if you did B and you pause the video, we're looking back here. We have, this one's just an easier one because it's just 1 by itself. So this one was just H. If it gives you the inverse, we're going to find the regular function. We just have to switch them back though. So this is technically our y and our x since it's an inverse with that negative 1. But again, just to find the actual function, you still flip them. You're doing the same thing, inverses. So this becomes h, and we don't need the negative 1 there, of 2, because that's really our x, equals 6. And it's that. That's it. So that's going back and forth. A and B were just going one way to the other. All right, and then C now is going to show us how to use a table and then the inverse function. So if we're finding an inverse function, I know I have to write my ordered pairs as f to the negative first, and then I have to write my y equals x, because remember, I am flipping things. So this now, this x becomes our y, and this f of x becomes our x. So these are now our x values and our y. So what we do is we flip the ordered pairs. So if this first one, I like to write it out to the side, is -2, -7. We just flip the numbers to find the first one. So our new x is -7 because we're flipping these. And this is equals -2. That's finding the inverse of this first ordered pair. Here's the next ordered pair. So for the regular function, it is -1, -3. So again, when we write the inverse, it's f to the negative first, and then we're going to pop in there, we have to switch these two. -3 equals -1. And then so on. F to the negative first, and then that's 0, 5. So I'm going to switch it to say 5, 0. 5 equals 0. And then the last one, f to the negative first. And then this last one, it was 1, 2, but we're switching it. The 2 goes here and the 1 goes here. And then the question was, is this inverse a function? Meaning, looking at our x values, the inverse x's. So when we switched them, do any of the x's repeat? And since they do not, the answer is yes. Remember, a function, every input, there's exactly one output. So that means x doesn't repeat. You might want to write that. That makes it easier to think about. Your x, or whatever your inverse x is, it just can't repeat. Whatever is in the y position, whether you're switching them to an inverse or it's the original y, they can repeat, but your x value, whatever is in the x value, cannot repeat. Okay, all right. The last part we have is finding inverse of a linear function using a graph. So this one automatically gives you the line. Remember, this is our y equals x line, and it's even labeled here. We're always going to use this one. We're going to use that as our point of reference technically it's reflecting over it. So we're going to use this as our reflection line. So finding the inverse, what that means is first I'm going to graph both of them. And then once we find the inverse, we graph both of them. So this is our original one. So to find my inverse, remember, I make this f of x equal y and this x, and then I switch the two. So this actually just becomes x equals 2y plus 4, and then I'm going to solve. Okay, and I have to do -4, so x minus 4 equals 2y. And then what I end up doing is I divide everything by 2, so I'm actually going to do that. When I go to graph it, it's going to make it a lot easier if I put it in slope-intercept form. So what I'm going to do is break these up. This is really like 1x over 2, so I write that as 1/2 x minus, and then I can actually do 4 divided by 2. So 4 divided by 2 is 2. So that equals my y. So remember, when I go to write it, it's really f to the negative first x. That's my y. Equals, and then I'm just going to rewrite it over here, 1/2 x minus 2. So again, so now I'm going to graph this original one, and I'm going to graph this one. So as you recall, when we graph, what we're going to do is we put our first point on the y-intercept out here. So I go to 4, and I put my point here, and then I use this slope to graph. So that means I would go up 2 and over 1, but if I go up 2 and over 1, I'm off the graph. So I'm just going to go the opposite. So instead of up and to the right, I'm going to go down and to the left, down 2 to the left, down 2 to the left, down 2 to the left, and then I'm kind of done. So right there, I'm just going to use a piece of paper to draw my nice straight line. You'll be using a ruler, hopefully. So this is my f of x. I'm just going to label it, that's my f of x. Now my other one, I can graph this. I put my point at -2, so you put your first point here. First point, that's called our y-intercept, meaning on the y-axis, so it's at -2. And then this is my slope. I go up 1 and over 2, up 1 and over 2. So if I look at this, I want to see where it's going to hit here. So I'm going to go the other way too. So down 1 and over 2, down 1 and over 2. They actually both meet right there. So I'm going to try to straight as I can. So there's the relationship right there, that ordered pair where they meet. Okay, so this is, we see it on a graph. So we just look at, we have to verify that they're actually inverses. So when I look at it, yes, it looks like I flipped 1 over that middle, that y equals x line. Okay, so I'm going to have you try B as a checkpoint. I want you to practice that one. So remember, you're going to first find the inverse function, and then you will graph both of them. Pause your video and give it a try, and then when you unpause it, I will walk you through it, and hopefully you get the same answer. Okay, so for this one, we would have had our f of x becomes a y, and so we would have x equals 1/3 y, because we're moving them into different positions, equals 2. So now I'm going to do plus 2, and I get x plus 2 equals 1/3 y. And then remember, we're going to multiply by a reciprocal, which is just 3. So I times by 3, or 3 over 1, but it's easier to just times by 3, the whole thing. So then I have to do the distributive property. So 3x plus 6 equals y. And then again, I have to change it. So it becomes f to the -1x. That's what we say y is, equals, and then we write our inverse function. So we're going to do both of these. We have to graph both of them. I'm going to look at graphing this one first, our regular function. Remember, we have to use this number out here to put our first point on. That's our y-intercept. So I'm going to put my first point on -2. So I go down to -2. I put my point, and then I use my slope to rise and run. The slope is +1, +3, so I go up 1 and over 3. 1, 2, 3, up 1 and over 3. I'm a little off the graph, so I'm going to go the other way. Down 1 and 1, 2, 3, left 3, down 1 and left. I'm off the graph. So this is a line. I'm going to use a ruler. Mine's a little note card, but same thing. Okay, so that's my regular function. That's my f of x. And then I'm going to do my other one. Okay, so I have to put my point at 6. So I'm a little off the graph, but that's okay. We're still going to make this work because we know how to count off the graph. So I'm going to go to 3, 4, 5, and I know 6 would be up here, right? So that's my first point. And then I go up 3, and if I wanted to, what this is really like 3 over 1. Or if I wanted to do, I got to go the other way. It's actually -3 over -1. So I'm not going to go up anymore. I'm actually going to go down 3. 1, 2, 3, and left 1. 1, 2, 3, left 1. 1, 2, 3, and left 1. And then I'm going to make my left. So those are reflections over the y. This is my f to the -1st x line, and that is my reflection. Okay, and the last part is my checkpoint. So the first thing I want you to do is pause the video, and I want you to just find the inverse function. I want you to do the work and find the inverse function. And then I'm going to walk you through using your graphing calculator to find an ordered pair that fits, because it's so much easier to use the graphing calculator. But first I want you to pause the video and write out the inverse function for me, because that's what we need to put in the calculator. So pause now and give it a try. Okay, so as you can see, I did a little bit of work on the pause, but we'll get to that in a second. So let's just write out this inverse. So remember, that changes to the y, and then we flip the x and the y, so it becomes x equals 5y plus 18. And now we're going to solve or get the y by itself. So I like to draw this in just to make sure my work is nice and neat. Minus 18 from both sides, minus 18, that cancels, and I get x minus 18. I'm going to draw a line there so you can see. Equals 5y. So then my last step is divide both sides by 5, divide by 5, the whole thing. And that cancels. So I get y equals that x minus 18 on top, all divided by 5. So I'm going to write my function over here. My y becomes f to the negative first, and then of x. So then I'm going to put x minus 18, put it in parentheses, all of that divided by 5. So that's my inverse function. We had to find that. Now we're going to use our graphing calculator. So if you want to pause and write down these steps, that'd be a great idea. So in our graphing calculator, I'm actually going to put my graphing calculator on the screen here so we can see the steps, my inverse function, and then how I'm going to just check the ordered pairs. So if I look here, I'm just going to clear that out. Let me just go back to the main screen. So my steps say we hit the y equals key. So I'm going to hit y equals. And so hopefully nothing's in there. If there is, you need to clear it out. And we're going to type in our inverse function. We're going to type in parentheses x minus 18, parenthesis, and then all of that is divided by 5. Okay, so to find ordered pairs, you might recall, we have to get to the table. So table's under graph, so we're going to hit second, and we're going to hit graph, which gives us a table. So then I'm going to go through every ordered pair. I'm going to look at the x's, and I'm going to see which one matches. You just go through them. So the first one I'm going to look for, well, here I'm on -8 for some reason. So here's a -8. Is the y2? So it's not that one. We can get rid of B. So now I'm going to go up to A, and I'm going to look for 8. So I got to arrow up and down. I want to get to +8. +8 is -2. So, +8 is -2. That tells me right there, this ordered pair is on that function, is part of it lies on that inverse function over here. So there's my answer. I don't have to go through, but if you want, sometimes there's more than one answer. So I'm going to go to -10 just to make sure that there's not more than one answer. It's -10, and then that one says 40. This says -5.6, so it's not that. And let's just go to -2, and that's -4. So that's not it either. So there's only one right answer for this one. Again, sometimes with PSAT, they have multiple, so we want to check them all. But that's all you do for that one. Okay, so this is our learning target 1.4 inverse functions. You are now going to attempt the practice and rewatch this video or certain problems as much as you need.